So yeah, the state of multisig, it's a way of creating a transaction output that requires a few signatures. And so this is like with a focus for hodlers. So for the people in this room, because this is like a hodler conference. And so some of the benefits, some of the considerations. I'm not a security expert, so I don't really want to be prescriptive, but just weigh some of the different considerations involved. So what it means like from a hodler perspective, so it's sort of an emphasis on saving and not spending a lot, institutional or individual instead of an institutional point of view. Multisig has a lot of institutional benefits as well, but that's not this conference, so we're not going to talk about it. Not your keys, not your Bitcoin. So it doesn't count if someone else is doing multisig for you and they have all the keys. That's not those aren't your keys. So don't trust verify. We want to be sort of try to pinpoint all the places where we're trusting something. And some of them are going to be kind of paranoid, but I think that's a good exercise to try to figure out exactly every place we're trusting something and failing to verify ourselves. And with some of this kind of state of multisig 10 years into Bitcoin, some of it's still hard to do. And lastly, whose consensus rules? So with some setups, it's difficult to choose your own rules. So what's the value proposition for multisig? No single point of failure. You want losing one key is kind of a catastrophic event that won't happen very much, but it can still happen. And if you can survive that, I think you can sleep a lot better at night. And so long as you can also like manage the increased complexity that goes along with it. So how? You create a spending policy which allows key loss without fund loss, and then you store your different you generate, store, and access different keys differently. So the idea is that if something goes wrong with one of them, that same problem won't go wrong with the others because each one was generated, stored, and accessed a little differently. So if you have like a hardware wallet attack, well, that one is only one of your keys. If the way you generated the randomness that went into the private key somehow became predictable, well, that method was only used for one private key. So the idea is any attack can only get you once. So you have to have multiple of these very low probability catastrophic events to lose your Bitcoin, which is really appealing. Yeah, and so like for example, 6 of 11 multisigs stored in your desk in plain text, unencrypted, like it's just a really complex single sig setup. There's no benefit at all, and there's a lot of cost. So like, I'm not saying like go do multisig. It's like there's cost to it as well. So yeah, some cons. It can be more complex, and complexity is the enemy of security. I still can't really see that very well. You must keep track of some extra information besides your private keys. Like there's this idea, it's called a redeem script. We're not going to get into that technical stuff too much here, but there's some piece of information besides your key that if lost, you can't access your funds. And that's considerable extra complexity. And inheritance, there's a lot of moving pieces that can be a little trickier for inheritance. But at the same time, having more dials to tweak can make inheritance a little easier because there's like no one person that's going to have the key that can just run off with it or something. You can sort of, the complexity can be put to good, that's way better. And so then on-chain fees, multisig has more, bigger scripts and more signatures. So that means the transaction that goes on the blockchain is bigger, so you get charged for that. It's still not a huge cost at this point. And there's off-chain fees, travel, repetition. You just have to sign multiple times. You want to have your keys in different locations, you got to travel, and then backups. But at the same time, these costs are direct security benefits. Like this is what you want. You want to have to travel a few places to access your key. So if there's a flood in one of them, you're fine. You want, yeah. So that's these are kind of like some of the direct. The benefits are tied to the costs. So here's an example. This is a beautiful ASCII art animation I've made. I'm not a very talented artist, but the idea is on the left side we have keys 1, 2, and 3. And at the bottom you see like that's time. So it's like the bottom is time. So like the left is early in time, to the right is later in time. And you can see like sort of now is where we're at. And let's say we have 3 keys. We're doing 2 of 3 multisig, meaning two keys have to be able to sign to move the coins. And there's 3 possible signers. At this moment in time, everything's safe. All the keys are good. It's all safe. We move forward in time. The keys are all safe. We're still good. Forward in time, keys 1 and 3 are still safe, but now key 2 is lost. For any reason, like it could be a natural disaster, it could be an accident, it could be a hack, it could be a bug. Like we can think of it abstractly. Like as long as we're doing each class of threat is sort of like approached a little differently on every key. It can be any one of them, and so we lost one. We lost key 2, and but we still have keys 2 and 3. So if we advance a little, like so we can say here like recover with keys 1 and 2. That's what we can do at this point because we can kind of weather this storm. It's like the next moment in time, keys 1 and 3 send to a new multisig, and so where we used to have like keys 1, 2, and 3, right? And like the next moment in time, now we have keys A, B, and C. We have a whole new multisig wallet. We had to pay some on-chain fees. We had to maybe do some travel and some other things, but we just weathered the loss of a key that is a lot of the time would go bad. Like you could have redundant copies of a single sig key. That's one way you could weather some of these attacks, but if it was like a bug, that your funds were gone in single sig, like a really bad bug. So that's the idea is, just to review, over the course of time, you encounter like a very low probability disaster, and you can recover. So that's the value proposition there. So some of the diverse key strategies I talked about, like obviously if it's on paper in your desk, it's a complete waste of time. But if you can have some geographic diversity, like put them in different locations, they could be different locations in a single town, or have one of them in a different state, or you can get really crazy. You probably don't want to go too crazy, but different jurisdictions, like if some jurisdiction comes out, starts drilling safety deposit boxes for the hell of it, if you're in a different jurisdiction, maybe both of them don't decide to drill safety deposit boxes. Hardware, so different chip architectures and vendors. The chips will have different vulnerabilities at different times, and a vendor, have different supply channel attacks. Nobody can pull a retirement attack at 2 different vendors, we hope. Software is so like the firmware or operating system that is like the base software on a hardware wallet or a laptop or something. And then a programming language. Different programming languages can have different bugs at different times. And again, these are all like very rare things. I'm not trying to scare you. Like this is very low probability, but yeah, and entropy, where you got the private key from, where you got the secret from. And so just to sort of zoom out, like let's think of what we do with private keys. We do 3 things. We generate them, we store them, and we interact with them. So pretty simple. So first one, key generation. So there's a couple ways to get a private key. So a private key is just a really huge number. So you just want to get a really random number, and the thing that's really protecting it at the end of the day is it's really hard to guess. And so randomness is important if you want something that's hard to guess, right? And so there's a few ways to do it, like hardware true random number generators, like that's what your laptop or your hardware wallet uses, and they get like physical environmental noise, like current on some connection or something, or like if it has like a Wi-Fi chip, it'll watch for fluctuations in like sensors or something. Dice rolls is a great one, but if you have good dice, if you have like casino dice, you just have to, like one thing we'll discuss later, they get the private key by rolling 62 dice. So roll dice 62 times, right? And there's also a keyboard. You can smash the keyboard for a while, and eventually you'll get some random, you can convert that into a random number. And like in theory, you can combine randomness. If you take a random number and add it to 100, it's still a random number. Like two things added together will be just as random as the most random one. So you don't like lose randomness by adding things together. So combining can be a strategy as well, but it's also a little tricky. So key storage, okay, that's the wrong number. Key storage number 2, so it's what to store. That's one of the tricky things, and we got to think about these because right, we want to have a couple keys and do each one like maybe somewhat differently. Like you could use this one, you could probably do the same thing for each one, but like for the others, you want to do them differently. So like paper could be, you could use paper. There's like fire resistant or water resistant paper. Steel is better at resisting water and fire especially, or metal, steel, or titanium. Bill Fodel is a company here that's, yeah, so talk to that guy. He's got some cool products. So that's what they specialize in. It's you put your mnemonic on this piece of metal and building it start on fire and you still got your mnemonic, which is pretty cool. Or electronically. So it's like, yeah, all of a sudden now maybe the hardware wallet, it's usually like a UI for your private seed, right? It's like how you look at a balance or how you accept a signature. But some people use it as the actual, like, the private key itself, the thing you guard with your life, right? And like CAS is one group that does that, where it's like they use it as both the private key itself kind of and the UI for it. Because normally, if you have a backup for your hardware wallet or USB or something, you can lose it because it's just like a way of accessing it. But if you don't have a backup, like you really can't lose that thing. And if you store it electronically, you're going to want a way to protect from like outside electromagnetic radiation that can screw up the what's being stored on the device. And another option is you can store the mnemonic and the passphrase separately. Like a mnemonic has like 24 words, and then the fifth one, you get a 25th, and that can basically be a password. And so you can choose whatever you want for that. So obviously, the benefit of this is like if they're stored separately, someone can find your mnemonic, but they can't even do anything with it because the passphrase sort of unlocks it. So if they're stored together, there's no benefit added. How am I doing time-wise? 20. Okay. Okay, so really 20 minutes. Okay. The question is where to store it. So like a bolted down fireproof safe, a custodian, safety deposit box, or bury it. You can put it in your brain as well. That's like beware if that key goes with you if you die. So key interactions is the big one. So there's like three things: sign a transaction, display an address or a public key, and then communicate either of these manipulations with an internet-connected machine that can actually access the blockchain, do stuff like that, talk to an exchange, sell your Bitcoin, buy more Bitcoin. And this process can, there have been attacks where you like leak the private key in this communication process. So it's like that's kind of a key manipulation or key interaction as well. And so some considerations when you're talking to the desktop, you want to like you want to just have one communication channel. Like you don't want to have someone looking over your shoulder, right? So there's like two communication channels. You don't want to have someone listening to you like roll the dice or something, or like listening to you enter your password. You just want to have one communication channel, and you want to completely control it. So like USB is hard to control. Like there's a Stuxnet virus Michael Flaxman likes to talk about. Set back was delivered to Iranian nuclear reactors via USB. It was just it's like an exploit they spread all around the world that they hoped would reach an Iranian nuclear reactor. And there's this rubber ducky that's an interesting one to read. USB chip, USB stick, pretends to be a keyboard, sends arbitrary keystrokes to your computer. You can just like install anything, which is terrifying, right? Like you could put this exploit on like a thing that looks like a Trezor, sell it, and like, cause chaos. So USB is tricky. QR code is harder to do stuff like that because it's just like passing data zeros and ones, and harder for the QR code to pretend to be a keyboard, right? So some key manipulation devices, there's two popular ones. One's like an air-gapped laptop, and the other one's a hardware wallet. So an air-gapped the idea of an air-gapped laptop, the reason why you want it, air-gap means like it's not touching the internet, basically, because the internet is like, I don't know, it's like a leaky valve. It's just gonna like, information's just going to spill out, and that's not what you want for your private keys. So you want to like make it kind of airtight, so not connect to the internet. You do that by buying a dedicated laptop that's not used for anything else. You can get like a $200 one. I'll mention something like a guide for doing this a little bit. You remove all the networking chips, which is error prone. Like this is, be careful with that. You want to make sure you actually do it right. You can use QR codes, which is nice, partially because you have a big screen. And you can use desktop tools like Electrum, especially Bitcoin CLI or Qt. And so one thing that uses this is Glacier Protocol. This is kind of outdated, a little bit outdated, but it's extremely proven. Instructions for set up multisig using Bitcoin Core command line tools. So it's probably quite secure, but it's very involved. But I think it's, if you want to learn about multisig, it's a very good read. You can read the document in like 20 minutes, and you see all these like crazy things they do. And I think it's very instructive to read and learn about, and it's been reviewed by security experts for like 5 years. So I would recommend this as just like reading. And you could try it, but it has some big drawbacks. Like you just get like a handful of addresses. You have to reuse addresses. It's quite difficult. But they describe this process of air gapping a laptop, which is, I think it's really interesting. Device number 2, Bitcoin hardware wallet, which you've all familiar with. Some of you in the audience make Bitcoin hardware wallets. So it's a tiny, cheap computer for only working with Bitcoin private keys. The idea is to mitigate remote attacks. So like somebody that's physically away from the hardware wallet can't extract keys, for example, or privacy or anything. They can't do anything. You have to like be physically there. And some of them even attempt to guard against physical attacks by someone who gets the device. Other ones really don't. So pros and cons, like the pros of a hardware wallet is it's off the shelf, easier than a laptop, diverse manufacturers, right? We want this diversity so that if there's a problem with one, the other ones are sort of unaffected. And you hear about these like horrible hacks at conferences. These guys like to attack each other, but few of them actually happen in the wild. I don't know if really anything has happened in the wild yet. Some of the cons are that they're honeypots. Like imagine how much money you could make if you could extract keys off all XYZ hardware wallet. Like right now there are better scams, like shitcoins. So all the people that could pull off these probably don't attempt it. But over time, as those scams go away, like this is going to probably be a really good scam. And you're going to have a lot of really smart people trying to do this scam. So address verification can be difficult for multisig. And there are limited desktop UIs. It's basically just Electrum. But that's changing. Part of the reason I got into this is I started writing a multisig UI. And I know Bitstein is actually writing a similar one. I know a few other people. So I think this is going to really change. I think 6 months from now, you're going to have a lot of really nice multi-sig UIs that are, work with your own node, work directly with Bitcoin Core, stuff like that, which is exciting. So hardware wallet with Electrum, that's what I'm going to discuss, kind of how to do that. So Electrum is currently the best UI to set up multi-sig. By default, it will leak your privacy, so you want to run something called Electrum Personal Server, which will talk directly. It's like an interface between your node and Electrum. A little terrifying, right? That the default is to tell all of your privacy information to like Chainalysis. So that's a big problem with Electrum. Doing directly to your Bitcoin node would be better. So here's some, let me see how this looks. Can you see that? So I'm just going to run through a couple screens for how it works, just to give you an idea of how you could set up multisig. So can you see that? So I'll just kind of narrate. You might not be able to see it so well. So like you create a wallet, you name your wallet. You can choose a couple options. Standard wallet is normal. Multisig is one of them. So you choose what type of wallet. I'd like to use multisig. It has like kind of a nice little slider. How many signers, how many total, and how many people need to perform a signature. So this is like 2 of 3, and I got that nice little pie chart. You can choose where you want to get the key from for the first signer. You can create a seed, you can try to import one, or you can use a hardware wallet and use the seed that's on the hardware wallet that was generated according to the instructions provided by the manufacturer. So I'm not going to show you how to set up hardware wallets because this is just about the multi-sig aspect of using a hardware wallet. So you can choose that, and here's a ledger plugged in. So pick the ledger, and you can choose what type of transaction you want. And there's like special SegWit versions of multisig that are a little cheaper, right? SegWit included a block size increase that was implemented by discounting signature data. Multisig has more signature data, so it got a bigger discount, so it's appealing. You can choose that, or like the legacy pay to script hash, and then you choose the path, like what child of the master key that's on the device do you want to use for this multi-sig wallet. Another way to do it is you can paste in a public key, so you can maybe just input the private key on for one of the devices and get public keys for other ones. So this desktop computer can only sign for one, and you do it kind of on multiple computers and then combine. That's sort of advanced user. I should probably skip that. And then you can encrypt the wallet. So I'm going to show you two exercises here: address verification and change verification on Electrum. And I think this is a little trickier than normal. Like it's kind of tricky to know what your receiving address. So how can you see this? It's all right. So this is just like a balance screen or a receiving address screen. And so if you see in the red circle there, there's like these three eyes that are really cool. In order to really verify, one of the ideas with hardware wallets is it's like you trust that UI, you do not trust your desktop UI, because your desktop can maybe have malware. Your hardware wallet should not. And so you want to be able to show receiving addresses on your hardware wallet. So these like little eyes in Electrum are really cool. They're supposed to show your multi-sig address on the device. For Ledger, it doesn't work, which is unfortunate. For Trezor, it does work. You see an address and you see the path, and it also says multi-sig 2 of 3. The tricky thing is you don't know what the other signers are that are producing this address. Like the Trezor can say, hey, I have one of the keys, but you have really no idea who the other ones are. They could be like a ransomer or something, who's going to now have 2 of 3 keys and be able to take your coins. Is that 10 left? Okay. By default, this is what you see with Cold Card. It's like, hey, I don't recognize, Cold Card actually makes you register a wallet on the device. You have to like opt into a multi-sig setup with different public keys. And so that's like, I think that's really reassuring. They're like saying, hey, I don't know about this multi-sig setup. I want you to actually declare that these 3 keys are part of a setup that you've opted into before I'm gonna even let you interact with it. So you send something like this to the Cold Card. You say, hey, I have a name, Trezor Ledger Cold Card, CA, it cuts off at 20 characters, but it would say Cold Card. And you can do this from Electrum. There's a pull request open that's gonna change. You say the policy, 2 of 3, this format, pay to script hash, derivation path, and then the 3 public keys. And so once you import something like that, it's kind of hard to see, but the Ledger or the Cold Card will be able to display an address, and then over a few screens, it'll say the wallet, the name of the wallet. Sort of on the left side here, you can see 2 of 3, and then it'll show each one of the. It'll just show the fingerprint and the derivation path. It's still kind of a work in progress, so it's kind of messing that up a little bit. But in principle, this is a lot better because it's checking against like a registered multi-sig setup on the wallet. So like if you have 3 hardware wallets, you're probably going to want to keep this one at home and put the other ones, the Trezor and Ledger, somewhere else, because this one does a lot more verification for receiving addresses, right? And if you're going to be redoing your cold storage, going to send some coins to yourself, you really want to be sure that you get those coins, right? It's not someone else sending you coins, it's you sending them to yourself from the hodler point of view. So I think this is like really cool. This is a nice way of doing it. Another thing is verification of change outputs, or change outputs. So Trezor and Ledger, or Trezor and Cold Card, it works pretty well. It just looks like normal. It says like this is who you're sending to, this is the fee, and it recognizes what the change is. Ledger, it doesn't. You confirm the first output, and like the address and the amount will scroll by. You control the second output, which should be change, and the address and the amount go by. And then the final screen is fees unknown. Like you want to send it. In a multi-sig setup, it's not so bad because you can do this verification on other devices, but the Ledger does not help you with that. So you can see, like, one of the things I'm trying to get at is the different wallets have different characteristics, and you sort of want to understand what you're dealing with on each one, and also that we still have a lot of work to do to make this really nice. So as like developers, I hope we can improve this so that each one helps you show which ones, your change addresses, your receiving addresses. That would make things a lot better. Lastly, there's some multi-sig services. So I'm going to go over a couple UIs for these. So Gemini, Coinbase, Zappo, non-starter for the hodler. They might do multi-sig, but you don't own the keys. You have no control over consensus. Forget it. So-called collaborative multi-sig. A couple companies now, Unchained, who's here, Casa, Brian is here from Casa, and Blockstream has Blockstream Green. They're like different levels of this sort of help with setting up a multi-sig. And some of the things they share is they have really slick UIs compared to like open source tools like Electrum. key management expertise to help a minority, you protect a minority of the keys. So like imagine if you're in a 2 of 3 and you lose one of your keys, like in that scenario you start to get worried about the other two. If you've already lost one, like maybe I'm not very good at this. So if you have another person helping you with one of those, that can be really nice. They can never spend your funds. And it also helps with like sort of paralysis by analysis. You just do what they say. And that's a lot easier. You know, if you look at all these things, you read the Glacier Protocol, at a certain point you're terrified, and you're just gonna like not do anything. And it can be significantly easier for your errors, right? Do you want your errors trying to sweep off Electrum, or do you want them to like talk to an expert in multi-sig custody and like be walked through it, right? That's a pretty big benefit, right? And once they get the coins, that can maybe these people can maybe help them figure out how to sell them in an intelligent way. I think there's a lot of benefits there. And so the business model is subscription, small fee, add-on services like a node in Casa's case, or loans, or in Blockstream's case. You know, you never quite know what their business model is. So costs, you generally lose privacy, so you're using a trusted UI that can see everything, see all your XPubs, all your public keys. No control over consensus rules in, I think, all these cases, or most of these cases, maybe Blockstream Green you can. You can't plug it into your own node, so if there's like some fork in the network, it's hard to, at the current moment, it's hard to choose which side you're on. But you can always like bail out to Electrum if you want to like participate in consensus in a very aggressive way. And most of them only support Trezor and Ledger right now, but hopefully that changes so we can get enough, as we get more good hardware wallets supported 5. All right, yeah, so Unchained Vaults. I'm just gonna run through, I'm kind of short on time here, so I'm just gonna run through kind of how this works. So the idea is like you got a vault set up, you got some money in it, now you wanna move it somewhere, right? So you tell them an address, you select an amount, fee and everything. And then you can choose some keys. So like these two on the left are like my keys. You can't really see it very well, but like that's my Trezor, my Ledger, right? Let's say like I've lost my Ledger right now. Like I'm in big trouble, right? And now I'm maybe worried about if I had a third key, I'd be worried about that one. Well, in this scenario, Unchained's got that third key, and well, I don't control that key. They're probably a lot better at protecting private keys than I am, because that's their whole thing, right? That's their entire core competency. So in this case, I use the one hardware wallet that remains. I sign. It gives you the screen. You plug in your Trezor. It just like pops up, asks you to sign. Really straightforward if you've ever used a hardware wallet. And then you wait for a signature from Unchained. They sign once a day. The next day, you got a signature. You can broadcast it, and it's really slick. I think this is a great offering. Casa Keymaster is another one. With both of these, it's like really hard to give them justice, or do them any justice in such a short presentation. So like, really look into them afterwards if you're interested. Like I can't, I think both of these guys will probably think I sold them short, because it's like it's like with 2 slides, what can you can't really explain all the thought and effort that went into these offerings. But they do it from like a really slick mobile app, and it's very good, the mobile app. And to facilitate setup and use, they have multiple options, 2 of 3 or 3 of 5, various levels of like hand holding as you go. When I talk to them, they're like, we want to hold your hand, not your keys, which is kind of a cool way of looking at it, right? Very different from a lot of the other businesses. And it's seedless, like I described earlier. So when you get the mnemonic, those like 12 or 24 words, you throw that away, which is very different. It's not how hardware wallets were intended to be used, which is a little scary, but it also is significantly simpler. You know, they have some world-class security experts on their team, so I think they've thought it through. And so you can talk to them more about that. So here's some like mobile screens. I don't know, this is like, it's not like, this is terrible. It's like the app is so beautiful, and this is like not really doing it justice, but you can see this like cool thing on the left. You sort of see the 3 keys you have. One of them is a home key, one of them is like office, one of them is somewhere else, one of them is Casa's key, and one of them is the mobile app itself as a key. So in a sense, like Casa kind of controls 2. The physical key is actually on your phone, but it's in their app, and it's hard to verify like exactly what code the app is running. So you know, they kind of control 2. 1.5 or something, and then they have this like safe key. This is the middle screen is like the example where you can like perform health checks on every key, see that everything is good, and you can try to like in a disaster scenario, you can try to you know, or I guess on the right side would be just spending. So you can choose which keys you want to spend with. This is going to be your mobile key, your hardware wallet, and somewhere else. So I think this is already signed by one. Maybe signed by one hardware wallet, then you're going to sign with your mobile key in another hardware wallet. And it's really cool. You just like you choose which one, they email you, and it pops up, and you can like, plug your device in and sign. You can do it on multiple computers. So it's a really slick offering. And these are great for the hodler, from the hodler point of view, because you can you basically get everything but control over consensus. You control the keys, you get some redundancy. But in the event of like some sort of fork, you could still like use Electrum, and they'll probably help you with that, and you can decide like which set of rules is Bitcoin to you. So this is kind of like an overview of some different ways to do it. In summary, like there's this air-gapped hardware wallet, or I guess a better way to say it. I'm missing like a conclusion slide. So if there's one thing I want to take away from you is that like if there's one thing I want you to take away from this is that multisig allows you to avoid single points of failure, so long as like you treat the keys differently. And hardware wallets are really good, and getting better. There's some UIs there's one UI that's good, and more are coming. And if you want some help protecting a minority of keys, there exist some very good services. So you should check it, look into all that. There's representatives from 2 companies here. And yeah, that's it. Thanks. I also want to thank Michael Flaxman. He's like, a lot of these ideas are sort of his. So we've been talking about this a lot the last couple months in Austin. So that's it. Thanks.